Welcome to this video. In this video, we're going to solve this coding interview question to sum. In this problem, we are given an array of integers nums and we are given an integer target. We have to find out a pair from this given array. We have to find out a pair that add to this target. Target equals to 9. So we have to find out a pair from this nums that add to this target 9. We see that we have here 2 and we have 7. If we add 2 and 7, what we get? We get 9. By adding this 2 integer, we get this 9. We find out this pair to 7. We have to return the index of this 2 number, which is 0, 1. So for this given nums array and for this target 9, we have to return this 2 index. We can return the index in any order. We can return in this order. First we have 1, then we have 0. We can return the index in any order. So for this given examples, we have to return these 2 indices as an array. For example, if we are given this nums array and target equals to 6, we have to find out a pair that add to this target 6. We see that we have this 2 number 2, 4. It's add to this target 6. So we have to return the index 1, 2. We find out this 2 indices. We find out these 2 indices where we have the number 2 and 4. If we add the number 2 and 4, we get the target 6. So we have to return this pair of indices. Now let's see how to solve this problem. For example, we have target equals to 9 and we have this integer array 2, 1, 3, 5, 8. First, let's talk about the naive solution. In the naive solution, what we are going to do, we are going to generate all possible pair from this nums array. And we are going to check if a pair add to the target, we will return the index of that pair. But this solution will take time complexity of n square. And it takes space complexity constant. This is not super efficient solution. If you came up with this solution in an interview settings, the interviewer will not be happy with this solution. We can improve this time complexity from quadratic to linear. Let's see how to solve this problem efficiently using hash map data structure. Now let's create our hash map data structure. This is our hash map data structure. As key, we're gonna store the element. As value, we're gonna store the indices. Now let's scan this nums array from left to right. Our current element is 2. If our current element is 2, we're gonna assume this 2 is the part of a pair that's add to the target 9. So what we should have here, if the one value of the pair is 2, what we should have here, that is 9 minus 2, 7, right? If we have here 7, it means that we find out a pair that add to the target 9. So we're gonna search the target minus current element. So 9 minus 2. Does 9 minus 2 exist in our array? Up until this point, we have processed this subarray. In this subarray, we see that 7 does not exist. So what we are going to do now, we are going to insert this 2 and the index of 2 in our hash map. So 2, this element 2 and index 0. Let's move forward. This is our current element. If we assume this one is the part of a pair that's add to the target 9, what we should have here, we should have here 9 minus 1, which is 8. Does 8 exist? How to check whether 8 exists or not in this subarray, excluding this current element? If we look at in our hash map, we see that 8 does not exist. So what we're gonna do, we're gonna add this one as key and as value, we're gonna insert the index of 1. So we have inserted the element and the index set. Let's move forward. This is our current element. Let's assume this 3 is the part of a pair that's add to this target 9. So what we should have here, that is 9 minus 3, which is 6. Do we have 6 on the left of 3? We have processed the left of 3, right? We are moving from left to right. Let's check here. Do we have 6? We don't have to iterate over this entire subarray. We can look at in our hash map. Now we're gonna check, does 6 exist in our hash map? We see no. So we're going to add this element as key and the index as value. Let's move forward. This is our current element. If we assume this 5 is part of a pair that's add to this target 9. So what we should have here, that is 9 minus 5, right? 9 minus 5 equals to 4. Here we should have 4. Does 4 exist on the left of 5? We see no. So what we're gonna do, we're gonna add this 5 as key and as value, we're gonna insert the index of 5, which is 3. Let's move forward. This is our current element. Now what we are going to do, we are going to assume 8 is the part of the pair that add to the target 9. So what we should have here, if we assume this pair add to the target 9, then here we should have the number 9 minus this value 8 equals to 1. If we have here 1, then this pair add to the target 9. Now we have to check, does 1 exist on the left of 8? We see that 1 exists in our hash map. We don't have to scan this subarray from index 0 to index 3. We know that we can check in our hash map whether an element exists or not in constant time. We see 1 exists, so we find out a pair that's add to the target 9. So what we are going to do, we are going to find out the index of our current element. Index of our current element is 4, and the index of this 1 that we have on our hash map. For 1, we see that we have index 1. So what we're gonna do, we're gonna return for 1. Also you can return in this order 1 4. This 2 answer is valid. You have to return the indices of the pair that add to the given target. This is how we can solve this problem. The solution takes time complexity O of n, which is linear, and it takes space complexity O of n as well. This is the complexity of our algorithm. We saw that in the naive algorithm, we solved this problem in O of n square. We improved this quadratic time complexity to linear time complexity. The space complexity was O of 1. The space complexity was constant. Here we see that the space complexity is O of n. We can trade off our space complexity for better time complexity. Now let's see the implementation of this algorithm. Now let's implement our algorithm. First, let's create our hash map data structure. In our hash map, as key we're gonna store integer, as value we're gonna store integer. Let's call it map equals to new hash map. Right below here, let's iterate over our given array. So int I equals to 0, I less than nums dot length I plus plus. Right inside here, let's find out the difference. So difference equals to target minus nums I. Now if we saw the difference does not exist in our hash map, map dot contains key difference. If we saw the difference does not exist in our hash map, what we are going to do, we are going to insert our current element and current index in our hash map. So map dot put current element nums I, then the current index, current element as key and the index as value. Here we're trying to find out a pair where the first element is nums I and the second element is diff. This is the first element of our pair, this is the second element of our pair. If we saw these two elements add to the target, then what we have to do, we have to return the index of this two element. If the difference exists in our hash map, this else block will be executed. Right inside here, what we're going to do, we are going to find out the index of our current element and the index of our difference. Let's create here an array int answer equals to new int of size 2. Here answer at index 0, we're going to insert the current index. At index 1, we're going to insert the index of our difference. So map.getDifference. This is our core algorithm. When we're done, at the end we are going to return our answer array. This is our answer array. This algorithm takes time complexity O of n and it takes space complexity O of n as well. I hope you've understood this video explanation. Now let's compile this code. We see it passed 3 sample test cases. Now let's submit it. We have solved this problem successfully. If you have any question, you can post your question on the Q&A forum. Thanks for watching this video.